Okay, so this one's going to be 6.6, exponential and logarithmic equations. We're going to use a lot of those properties that we talked about earlier in helping us solve these problems. So again, here was our properties of logs. And we went over that in the last video, okay? So I have a little note here. Make sure you always check your answers to see if it fits the domain. If not, you will need to reject this answer. So we'll do some examples and then we'll talk about that important note, okay? So log base 3 of x equals 3. So we can use, now notice we are going from, we talked about this earlier too, right? Going from a logarithmic equation to an exponential equation, and we talked about how we need to make sure we can go back and forth. Okay, so so this is a logarithmic equation, and we're going to rewrite it as an exponential equation. So this is going to be 3 to the third is equal to x, while x is going to equal to 27. Okay, so log base x of 1/8 equals to 3. This again is in logarithmic form, so we're going to write that in exponential form. So it's going to be x to the third equals 1/8, right? So you can do this in one of two ways. You can take the cube root, right, of both sides, and then this will tell you that x is going to equal to 1/2. Okay, and then this last example, again, it's in logarithmic form. We want to write it in exponential form, so it's going to be 4 to the power of 2 is equal to x squared plus 9. Now, we're going to bring everything to one side of the equation. Minus 16 is equal to 0, okay? So this is in turn going to become x squared, right? 9 minus 16 is going to be minus 7, right, is equal to 0. So x squared is equal to 7, and we're going to take the square root of both sides, and x is going to equal to plus or minus square root of 7. Okay? So now we have log base 5 of the quantity 4x plus 5 equals 2. So again, we have a logarithmic equation. We're going to write that as an exponential equation. So this is going to equal to 5 to the power of 2 is equal to 4x plus 5. This is going to be 25 is equal to 4x plus 5. And we will have 4x is equal to 20. Divide both sides by 4. And this tells us x equals 5. Okay. So the important thing is that when you have log base anything, okay, the input cannot be negative. So you cannot have the quantity 4x plus 5 cannot be negative. That's my input, okay? So this right here, okay, this right here cannot be negative, 4x plus 5. So when we plug in x equals 5 in there, right, we get a positive value because we get 4 times 5 is 20 plus 5 is 25. So it's positive. So therefore, this is okay, and this is going to be in the domain. This checks, okay? That's the note that we're talking about, this important note. We need to make sure that the input value, okay, is not negative. Let's do another example. So log base 1/2 of the quantity 3x minus 7 is equal to 3. So we're going to rewrite that in exponential form. That's going to be 1/2 to the power of 3 is equal to 3x minus 7. We're going to continue to solve this. This is 1/8 is equal to 3x minus 7. And I'm going to multiply both sides of the equation. Okay, I'm going to multiply both sides of the equation by 8 just to get rid of that fraction. This will give me 1 is equal to 24x minus 56 because I distributed that 8. And now I have 24x is going to equal to 56. Oh no, I'm sorry, I'm incorrect. I'll just leave them on the other. Okay, so I have 1 on the left-hand side. I'm going to add 56, so I'm going to get 57. So now I'm going to divide by 24 both sides. And I'm going to get x equals 57 divided by 24. Okay, and then the next example, again, we're going to use, you again want to check to make sure the value is not negative, okay? So when we check this value, right, we want to plug it in here, right? So 3 times 57 over 24 minus 7, right, has to be greater than or equal to 0. So notice that you're going to get 8 here. So 57/8 is going to be, notice that 57/8 is going to be bigger than 57/8. It's going to be larger than 7. This is about 7.125, right, minus 7. So it is greater than or equal to 0, so it checks. So that's in the domain, okay? As long as it's positive, right, it's in the domain, so it checks. Now let's do this last one. So we're going to first use some of those properties to move the factor into the power position. So this is the same thing as log base 7 of x squared is equal to log base 7 of 16. Now we can say x squared is equal to 16 and solve this equation, okay? So take the square root of both sides and you're going to get that x is equal to plus or minus 4. Now you want to check the domain, right? So when you put in a positive 4, right, notice that you have log base of a positive 4, okay? So this one checks, right? Because it's log base 7 of 4, and 4 is positive. But then negative 4, right? When you check log base 7 of negative 4, you can't have that, okay? So your only answer is going to be x equals 4, only the positive 4. You have to discard the negative 4 because you can't take log base 7 of a negative 4. So that's the important note, okay? Let's continue to solve some more. Now we have log base 8 of x plus 7 is equal to 1 minus log base 8 of 2 minus x. So we are going to bring all the logs on one side. So I have log base 8 of x plus 7, and I'm going to bring the other log on this side, log base 8 of 2 minus x, and leave the 1 on this side. Now I'm going to use the property to turn the summation into multiplication. So I'm going to do log base 8 of x plus 7 and 2 minus x. So I used that property number 6, okay, to turn the summation into multiplication. And now I'm going to go from a logarithmic equation to an exponential equation. So now it's going to be 8 to the power of 1, right? The 8 came from here, the power of 1 came from here, is equal to x plus 7 times 2 minus x. Now I'm going to multiply my right-hand side. So when I FOIL all this out, this becomes, when you multiply all these terms, right? The first terms, you get 2x, right? That's the first terms. And then the outer terms is going to be minus x squared. The inner term is going to be plus 14. And the last term is going to be minus 7x. Now, let's simplify this. I, again, have 8 is equal to, I'm going to write it in order, minus x squared minus 5x plus 14. Now I'm going to bring everything to the right-hand side, or actually bring it to the left-hand side so that x squared becomes positive. So I'm going to bring it to the left-hand side, minus x squared, okay, plus 5x, minus 14, and then I have the 8 plus 8 on this side. So now it simplifies to x squared plus 5x, x squared plus 5x minus 6 is equal to 0. And now I can factor this into x plus 6. X minus 1 is equal to 0. This gives me x equals negative 6, x equals 1. So I need to now check if they're in the domain, right? So when I plug in x equals negative 6, okay, so check, x equals negative 6. So I look in here, negative 6 plus 7 is positive. 2 minus a negative 6, that's also positive. So x equals negative 6 checks. Now I'm going to check x equals 1. So when I do x equals 1 in here, that's 8, that's positive. And when I put in x equals 1 in here, 2 minus 1 is 1. Well, that's positive also. So they both check. So therefore, my solution is going to be both of these values. Okay, so the next one, log base 2 of x plus 11 plus log base 2 of x plus 7 is equal to 5. So this is going to equal to log base 2 of x plus 11. I'm going to use the property to combine them. Just like the previous problem, now I'm going to go from logarithmic to exponential. So it's going to be 2 to the 5th is equal to x plus 11, x plus 7. And this is going to equal to 32 is equal to x squared plus 18x plus 77. Now, bring everything to one side. You're going to get x squared. Oops, I know, I think I did that wrong. Did I? Well, maybe I didn't. 18x plus 77. Now you're going to get x squared plus 18x plus 45 is equal to 0. And now I can factor this out. X plus 3, x plus 15 is equal to 0. I get x equals negative 3, x equals negative 15. I have to check if they're in the domain, okay? So I'm going to check x equals negative 3 in here. So negative 3 in here gives me a positive 8. Negative 3 in here gives me a positive 4, so that checks. X equals negative 15. When I put negative 15 in here, that's negative. So that automatically tells me that's not going to be in the domain. So my only solution is going to be x equals negative 3. So I have to discard the negative 15. Okay, then I have log base 2 of x plus 3 minus log base 2 of x plus 5 equals 1. Again, we're asked to solve. So we're going to use the properties to combine them into a single logarithm. So we're going to do log base 2 of x plus 3 over x plus 5 is equal to 1. Now we're going to write this in exponential form. So you get 2 to the power of 1 is equal to x plus 3 over x plus 5. Now you're going to cross multiply, which means you're going to multiply both sides of the equation by x plus 5. Well, I mean, you can cross multiply or you can do this. And now you're going to get 2 times x plus 5 is equal to, because x plus 5 divided by x plus 5 is 1, is just going to be equal to x plus 3. Distribute, you get 2x plus 10 is equal to x plus 3. And now you're going to bring everything to one side. You get x, subtract x from both sides, you get x, and then you subtract 10 from both sides. You're going to get 3 minus 10 is minus 7. So now you're going to check to see if x minus 7 is in the domain. So when you put minus 7 in here, well, that's negative. So automatically that tells you it's not in the domain. So x equals negative 7 is not in the domain. So therefore, for a problem like this, you say no solution. Okay, and then this one you have log base 2 of x minus 3 plus log base 2 of x minus log base 2 of x plus 2 equals 2. Well, there's a couple of properties you're going to use here. So you're going to do log base 2 of x, right? This x times x minus 3. Okay. Divided by x plus 2, because then you have subtraction. Okay? So this x and this x minus 3 goes in the numerator, and then this one goes in the denominator because of the subtraction. Is equal to 2. Now you have a logarithmic equation. You can write this in exponential form. 2 to the power of 2 is equal to x times x minus 3 over x plus 2. Multiply both sides by x plus 2. And this will get you 4 times the quantity x plus 2 is equal to, these two become 1, x times x minus 3. Now you can distribute, you get 4x plus 8 is equal to x squared minus 3x. This equation is going to be x, let's bring everything, well, let's bring everything to the right-hand side. So I'm going to have 0. On the left-hand side, I'm going to have x squared minus 3x, and I'm going to subtract 4x and subtract 8. So this gives me x squared minus 7x minus 8 is equal to 0. And you can factor this into x plus 1, x minus 8. And this gives you x is equal to minus 1, x is equal to positive 8. Now you need to check if they're in the domain. So when x equals negative 1, you put it in here, negative 1, minus 3, well that's negative, so that's not going to be in the domain. Now check x equals 8. Well, when you plug in x equals 8 here, x minus 3 is positive 5. When you plug it in here, that is also positive. So therefore, this will be your only solution, x equals 8. Okay? Equal base properties, a to the u equals a to the v, then u equals v. Okay, so if we wanted to solve these problems, what we're going to do is we're going to say, well, what is log base 4 of 64? Well, let's turn that into equation. Log base 4 of 64, say, is equal to x. Well, now we have a logarithmic equation, so we're going to change logarithmic equation into exponential, which is going to be 4 to the x is equal to 64. Well, in order to use this, we have to have the same base on the right-hand side and the left-hand side. So let's rewrite it. 4 to the x is equal to 4 to the third, which is 64. And once we write it like that, then we can use the equal base property and say x is equal to 3. Okay. This next one, let's write it first as log of, you're going to have, it's in the denominator, right? So it's going to be 10,000 to the negative 1 is equal to x. Let's rewrite that as log of 10, right, to the 4th to the negative 1 is equal to x. Now you're going to get log of 10 to the negative 4 is equal to x. So now you have exponential and you can write it, remember this is base 10. Now you can write it, you have logarithmic and this is log means base 10, so now you can write it in exponential. So you're going to say 10, that's the base, right? To the power of x is equal to 10 to the negative 4. So from here, you can see that x is going to equal to negative 4. Okay, notice that we set this equal to x, so we're finding exact values. So that's what the value is going to be, right? This x has this value. So for example, the next example, you have solve 4 to the power of x minus 2 is equal to 64. We're going to just write it as 4 to the power of x minus 2 is equal to 4 to the third. And now we can set the exponents equal to each other and solve for x. We get x is equal to 5. And the next example, right, we have a 1/2 on the left-hand side, and we have a 4 on the right-hand side. So let's try to see if we can write it as a base 2 on both sides. So if I write 1/2 as a base 2, that's going to be 2 to the negative 1. That's 1/2 to the power of 1 minus x is equal to 2 to the power of 2. So now this, I can write 2 to the power of negative 1 times 1 minus x is equal to 2 to the 2. This gives me 2 to the negative 1. Remember, I can distribute. Negative 1 times 1 is negative 1. Negative 1 times negative x is plus x is equal to 2 to the 2. So now I can set the exponents equal to each other. And I get x is equal to 3. So this next problem, I have 27 base on the left-hand side, 9 base on the right-hand side. So I can write them both as a base 3. So let's write 27 as a base 3. So that's going to be 3 to the power of 3. That's 27 to the power of x plus 2. And 9, I can write that as 3 to the power of 2. to the power of 2x. So now I just use laws of exponents, right? So this means the same thing as 3 to the power of 3 times x plus 2, because I can multiply those exponents. And this will be 3 times 2 to the power of 2x. I can multiply those exponents. So now from here, you can just let those exponents equal to each other. 3 times x plus 2 is equal to 2 times 2x. You have 3x plus 6 is equal to 4x. And you're going to have x is equal to 6. E to the power of 3x plus 5 is equal to 1. So we can again write them as e to the 3x plus 5 is equal to, I have a 1 there, so I'm going to write that e to the power of 0. So now I can set the exponents equal to each other and solve for x. Divide by 3 both sides, I get x is equal to negative 5/3. Okay, this next one, I have a 2 on the left-hand side and 8 on the right-hand side. I'm going to try to use base 2. So I'm going to write, this one is already a base 2. I can write that as x to the power of x minus 2. Now on the right-hand side, I can write that as 2 to the 3rd. Now I can set the exponents equal to each other and solve. So I get x squared minus 2x is equal to 3. Solve, subtract 3 from both sides. Now I can factor x plus 1, x minus 3 is equal to 0. I get x equals minus 1, x equals 3. Okay. And this next example, I have 3 to the x equals 7. Notice that I can't use the same base on the right-hand side and left-hand side. So in this particular problem, what I'm going to do is I'm going to take the natural log of both sides. Well, what does that do? Well, that lets me bring that exponent down, right, and write it as a factor. Using those properties. And now that I've brought it down as a factor, I can now solve for x by dividing both sides of the equation by natural log of 3. This next example, again, we can't use the same base, so we're going to use the same idea. Take the natural log of both sides. Notice that you can take the natural log of both sides, or the log of both sides, it doesn't matter. Okay, so what this will allow us is to bring that power down. So I have x plus 1 times natural log of 2 is equal to 1 minus 2x, because that's the exponent, natural log of 5. Now I have, now I'm going to have to distribute, okay, this. I have to distribute this to remove the parentheses. So I have natural log of 2 times x. So I'm going to write it as x natural log of 2 plus natural log of 2 times 1, which is just going to be natural log of 2. I have natural log of 5 times 1, which is going to be natural log of 5. And then I have natural log of 5 times a negative 2x. So I'm just going to write that as a minus 2x natural log of 5. Now I'm going to bring all the x terms to one side. So I'm going to put x natural log of 2 and bring the other one on this side as well, on the left-hand side. And then on the right-hand side, I have natural log of 5 left, and I'm going to subtract the natural log of 2. Now, you can, on the left-hand side, factor the x, because the idea is to solve for x. So if we factor the x, we're going to have x times natural log of 2 gives you the first term, plus 2 times natural log of 5 gives you the second term, is equal to natural log of 5 minus natural log of 2. Now you're going to divide both sides of the equation by natural log of 2 plus 2 natural log of 5. Divide natural log of 2 plus 2 natural log of 5. This gives you x all by itself on the left-hand side, and on the right-hand side you have natural log of 5 minus natural log of 2 divided by natural log of 2 plus 2 natural log of 5. Okay, this one's a little bit different. Okay, we're going to use this substitution process. So it's 3 to the power of 2x minus 3 to the power of x minus 72 equals 0. So what we're going to do is we're going to say, let u equal 3 to the x. If let u equals 3 to the x, then u squared is going to equal 3 to the power of 2x, because we just squared both sides. So now you're going to substitute the u and u squared into your original equation. So you're going to have u squared, because u squared is equal to 3 to the power of 2x, minus u, because u is equal to 3 to the x, minus 72 is equal to 0. Now by substitution, you can now factor this into u minus 9, u plus 8 is equal to 0. So now that you're able to factor it, you can plug in those u's back in here. So u is equal to 3 to the x. So you can write that as 3 to the x minus 9. And then we have u plus 8, so it's going to be 3 to the x plus 8 is equal to 0. Now set each factor equal to 0 and solve. So you have 3 to the x minus 9 is equal to 0. 3 to the x is equal to 9. Now you can use the equal base property to solve, and you have x is equal to 2. And then the other one, the other factor is 3 to the x plus 8 is equal to 0. You have 3 to the x is equal to minus 8. Okay? Now, we can't use the same base, so we have to take the natural log of both sides to bring that power down. Natural log of negative 8. So right here, remember natural log of negative 8. We can't take the natural log of a negative number, so therefore we can't even solve that equation. So our only answer is going to be x equals 2. Okay, we'll do one more like that, okay? 2 to the power of 2x minus 7 times 2 to the x plus 12 equals 0. So again, we're going to use substitution. U equals 2 to the x. Therefore, u squared is going to equal to 2 to the 2x. Now let's rewrite the original equation. So I have u squared minus 7u plus 12 equals 0. Now I'm going to factor this into u minus 3. And then u minus 4 is equal to 0. Plug my u's back in there. I have 2 to the x minus 3. 2 to the x minus 4 equals 0. Set each factor equal to 0 and solve. 2 to the x is equal to 3. Take the natural log of both sides. Natural log of 2 to the x is equal to natural log of 3. This becomes x natural log of 2 is equal to natural log of 3. X is equal to natural log of 3 divided by natural log of 2. So that's one value, okay? And then the other one, 2 to the x is equal to 4. 2 to the x is equal to 2 squared. X equals 2. So this is your other answer, okay? That will be it for this video, and then let me know if you have any questions, okay? Talk to you guys later.